Hi, hello, vanakkam, and welcome back to yet another interesting episode on your favorite Little Slaw YouTube channel. So, today I want to start with a statistic that might shock you because more than 50% of application performance bottlenecks don't originate where you think they do. They don't come from your React components, your microservices, or even your cloud infrastructure. They come from a place most developers treat as an afterthought, the persistence layer. While your team is busy optimizing the UI rendering and API response times, your users are actually waiting for something much more fundamental and database queries that should complete in milliseconds but are taking seconds instead. So the key points here is you should look at the databases and we're going to look for the shocking reality in our next slide. So let me repeat this because it's crucial, and more than half the application performance bottlenecks originate in the database. This is not just theory, this is the harsh reality playing out in production systems every day. And think about your last performance crisis. I'll bet someone said the front end is slow or the API is timing out. But when you dug deeper, what did you find? Database queries running for 30 seconds. Connections timing out. Lock contention bringing your entire application to its knees. So where my system break? That's what I have to understand, right? So most bottlenecks lurk deep within what we call the persistence layer, that critical junction where your beautiful application code meets the raw reality of data storage. And this is not just a backend problem that you can delegate to your database team, because every engineer who is building scalable system has a responsibility here. And when you React, or when your React app makes an API call, or when your microservice processes a request, or when your batch job runs overnight, they all depend on this layer performing flawlessly. And moving on to the fourth slide, where we look for why the JDBC still rules. So the foundation is, now some of you might be thinking we use Hibernate, we use JPA, we don't touch the JDBC directly. Yes, you're right. But here's the thing, despite all the sophisticated arms we have today, JDBC remains the foundation that directly communicates with your databases. Hibernate, JPA, MyBatis. So they're all just abstractions which are built on top of JDBC. And when any performance issue strikes, and they almost always stem from how JDBC is being utilized under the hood. So whether you're managing connection pools, executing complex joins, or optimizing the batch inserts, it's always good, or it's always better to understand the JDBC behavior, which is essential to diagnose and resolve these issues effectively. And moving on to the next slide, and talking about the only metrics that matter. So enterprise application performance ultimately comes down to two fundamental metrics, and only two, just two. They are response time and throughput. So response time answers how fast can a single operation complete. We all know that. And then the throughput answers how many operations can your system handle per unit of time. And here's the critical relationship. So throughput equals transaction count divided by time. So to improve the throughput, you must reduce the response time of every component in your transaction pipeline, starting from connection acquisition to query execution to response delivery. And this is where most systems fail, and they optimize everything except the data access logic, which needs to work in harmony with underlying database behavior. And moving on to the next slide, the sixth one, where we discuss about the dangerous myth. So myths are always dangerous, but again, this is a very dangerous myth that has destroyed more systems than I can count, and more database connections equal better performance. Please raise your hand if you have ever been in a meeting where someone suggested solving a performance problem by just increasing the connection pool size. So keep those hands up if it actually made things worse. Because this myth is seductive because it seems logical. More resources should mean better performance, right? but it's wrong. And the mathematics will show how you exactly are, like, will show you exactly why this thinking is not just incorrect but very dangerous. And let's move on to the next slide. So we all know about the universal scalability law. So welcome to the universal scalability law. This is not just theory, this is mathematical. It's reality that governs every distributed system you will ever build. So the formula shows us that scalability is not linear. It flattens and can even drop as the contention and the coherency costs rise. So alpha represents contention. Think shared resource delays. Beta represents coherency, the cost of keeping data consistent across sessions. So we have two items. One is the alpha and the other one is beta. So alpha represents the contention, think shared resource delays, and beta represents coherency, the cost of keeping data consistent across sessions. So the brutal truth here is, after a certain threshold, adding more database connections don't just fail to improve performance, it actively hurts it, because more connection means more contention for logs, more overhead for the database engine, and more coherency costs for maintaining consistency. And moving on to the 8th slide, your system's fatal weakness. So here is something that might be uncomfortable to hear: a weak skill that can break the strongest architecture. So your system's strength is not defined by whether you're using Kubernetes or whether you have adapted microservices or whether you're running on latest cloud infrastructure. It is defined by your team's depth of understanding of the underlying systems they're building on. And here is the harsh reality: the weakest skill on your team will eventually define your performance ceiling. So you can have the most brilliant architects, the most elegant code, the most robust infrastructure, but if your developers treat the database as a black box, you are bound to experience performance disasters. And moving on to the slide 9, the black box trap. So this is more interesting, because if your developers treat the database as a black box, you're setting up yourself up for failure. And database knowledge is not just for DBAs anymore. That's an outdated organizational model. Because every performance conscious engineers needs to understand the index strategies and partitioning. They need to know how write ahead logs work and what transaction isolation levels mean for their application. And they need to understand the query planning and execution path. Because when a system is down at 2 a.m. and users are screaming, you can't wait for DBA to analyze the problem. You need every engineer who is capable of understanding what's happening at the persistence layer. And moving on to the 10th slide, where you have to read the database manual. Yes, I hear this objection all the time. I'm not DBA. Why should I read the PostgreSQL documentation? And here is why. Knowing database specific optimizations can literally make the difference between millisecond responses and complete timeouts. And understanding how PostgreSQL handles concurrent transactions differently from MySQL, or how Oracle's cost-based optimizer makes decisions. And this knowledge directly translates to better application performance. And just like knowing how the JVM works make you a better Java developer, knowing how your database thinks makes you a performance first engineer. The database manual, like I told you, for example, here the PostgreSQL is not just a documentation, it's a roadmap to building systems that scale. And moving on to this 11th slide, the performance first mindset. So it's no longer enough to just make it work. In today's competitive landscape, you must know how it works, and more importantly, why it slows down. And this requires a fundamental mindset shift. So master the JDBC essentials, understand connection lifecycle, statement types, and result set handling. Learn your SQL dialect. Every database has optimizations and quirks. So use mathematical principles like USL, the Universal Scalability Law, to guide your architecture decisions. Performance is not something you add later, it's something you design from the beginning. And finally, the last slide, where you're going to discuss about from crawling to flying. So we have reached a critical momentum in our industry. Your system's success is not just about features anymore. Users expect features that are fast, reliable, and scalable. So you have a choice to make. You can continue debugging performance issues reactively, firefighting problems as they emerge, patching symptoms without addressing root causes, or you can master the fundamentals that prevent these problems from occurring in the first place. So the formula is simple: knowledge plus action equals performance mastery. So the database layer does not have to be your system's weakness, it can be your competitive advantage. So now the question here is, before I end, are you ready to transform from a developer who just makes things work to an engineer who makes things fly? Thank you so much everyone for watching this video. See you all in our next video. Until then, bye bye from Mr. Shanmugam and your favorite Little Star YouTube channel. Take care and bye.